designing the Creative College's new campus, the challenge becomes in producing a school that can match its world-class standards in excellence. We strove to seek solutions and strategies that would cultivate a sense of community, champion an approach of environment consciousness, maintain a quality of comfort, and encourage an atmosphere of creativity. Set in Bristol, the school will serve students ranging from 3 to 18 years in age, with the site exposed to average lows and highs of 2 and 22 degrees centigrade throughout the year, and not quite being the sunniest place in the world, and especially so in winter. The campus had to be designed to work in conjunction with the climate and environment it's in, and not against it.
With the site being an unobstructed expanse of land, we began by looking at the simplest module that would allow us to maximize southern exposure and optimize daylight. The concept evolved through a number of stages. Various configurations were evaluated by combining different functions within a single block to separating them and reconnecting them to social spaces. The iterative process resulted in zones with higher noise levels being segregated from teaching spaces to a series of terraces. The landscape terraces, formed in part by soil extracted from on-site building excavations, would serve dually as a buffer as well as a recreational realm, integrating the school with the site and the buildings with each other.
Spaces that could benefit from passive heating and demanded higher luminous levels were initially identified and were prioritized based on the frequency and duration of their use. Student classrooms, offices, and social spaces, such as the dining hall, were placed facing south, while spaces with intermittent use, like staff rooms, labs, and sports halls, were aligned to the north, east, and west. During the summer months, the segregation of social activities in the shared block would allow for the larger community to benefit from campus facilities, like the swimming pool, gym halls, and auditorium.
Several daylighting strategies were studied, optimized, and employed throughout the campus. In order to limit excessive solar gains and tackle glare, we examined a variety of shading devices for the classrooms. In other parts of the school, clear stories were used to light up corridors, and a north-facing skylight was introduced to provide the library with diffused light and block out the direct sun. Spaces partially submerged below ground level, such as gym, computing, and science labs, were lit up using high windows.
In line with the project vision, it was clear that using traditional construction materials would just not cut it. A solution was found through a local Bristol-based company, with walls constructed of straw bale panels, sandwiching the layer of pent insulation, all enclosed within a timber frame. A protective clear render on interior and exterior surfaces with timber cladding still allows for a breathable construction. Straw bale is a responsibly sourced, low-cost, recyclable, proven technology that delivers the results needed with minimum waste using locally sourced raw materials and manpower. Not only do straw bale panels offer a design that is low in embodied energy and in associated carbon emissions, it can in fact prove to be carbon positive. This means that it can actually absorb carbon out of the atmosphere for the duration of its lifespan, a lifespan which is comparable to other conventional materials. With the terrace design, some sections of the buildings will be semi-buried, incorporating the earth as a component in the building envelope, thus taking advantage of the reduced exterior temperatures underground, while maintaining indoor comfort levels.
Currently, in the UK, space heating accounts for nearly 80% of direct carbon emissions associated with buildings and 60% of the total energy consumption in schools. The concept of our comfort strategy is based on passive techniques that have been used by mankind since thousands of years, combined with the notion of adaptive thermal comfort. The system operates during winter by elevating the temperature of incoming fresh air using waste heat from the CHP plant. As it further gains heat from the occupants and equipment inside the school, air rises and is drawn out of the buildings through a solar tower using a combination of buoyancy and the Venturi effect. This process continuously eliminates the buildup of stale air. In summer nights, the building will be ventilated by cool ambient air which extracts heat from the building structure. By opting for straw bale walls with a relatively high thermal capacity, These walls will be able to maintain their cool throughout the day and ensure a comfortable environment for the students. Depending on ambient conditions, fresh air will be introduced to the school either directly or by being slightly pre-cooled through an underground air channel where it exchanges heat with the soil.
The integration of the different disciplines ensured that the proposed school design implemented sustainable principles on a comprehensive level, resulting in a low-carbon, low-energy building that exceeds current benchmarks. Ultimately, the final design will prove to be a natural extension of the environment it's in, a vessel that satisfies the aspirations of the creative college and the students it serves in an environmentally conscious atmosphere that maintains a strong sense of community, comfort, and creativity.